So how do we know if something is good for us in the long term, if it's good for longevity, if it's going to make us live longer? For example, creatine, for example, glycine, and many other things. Well, the first option is to have a double-blind clinical trial that lasts several decades, quite a lot actually, in order to see who dies and who doesn't. The trouble is that you will probably be dead by the end of the experiment, and if not, it will be too late for you. And in any case, there is no market, no longevity market that way that is robust. So you need to complement human monitoring with animal monitoring. There is no other way for long term, where animals live shorter than us in order to shrink several decades into, in this case, 1 month. So 1 month because these little animals that we are going to see moving, called Daphnia, and that you can see anywhere in the world, in lakes, in ponds, just take some water and you will wait for a few days and you will see them moving. So these Daphnia, they live naturally about 1 month. And they are a bit like us. They have a heart, they have kidneys, etc. If you put coffee in the water, they will be agitated. If you put alcohol, they will swim strangely. So they are a bit like us. They have behaviors, and you can see if they are healthy. So here I have been inspired by the work of Dr. Leon Peshkin, who is also a friend, and who made an article with his lab at the Harvard Medical School that shows that it's possible to have an aquarium, a bit like this one, with some light behind and a camera, and to study if the animals live long or not with different molecules. So I have reproduced this in Paris, or slightly south of Paris, with a citizen lab that I have the chance to lead every Saturday called KL. And now we start to have great results. So I'm going to show you. So this is an aquarium I made with the camera on a Raspberry Pi, a robot that goes in front of different aquariums and has a program, AI program embarked, as you can see, to put in red and blue lines the trajectories of Daphnia. So as you can see, probably it's very precise. In fact, it's even more precise than our eyes. I did check with the physical reality that it was able to see the Daphnia well. And so with this, you can infer if the Daphnia are healthy or not, especially if, it's not shown on this video, the robot vibrates one side of the aquarium, because then it's like a fish. And in the wild, the Daphnia are mostly eaten by fish, so they are afraid of fish. When it moves, ooh, they don't know what it is. So you can see them running, I would say, more or less fast, and so you can know if they are healthy. So there are different other ways to measure their health, but the thing is, we shrink longevity in people into something that lasts 1 month, so decades into 1 month. And that's a complementary way to monitoring people to estimate if something is good for longevity and for our health. So I am doing the same also for mice, where I have a patent to atomize their lifespan as well. And so with this, we are able to have, I would say, a pipeline from Daphnia to vertebrates to humans. And it's a parallelized pipeline in order to rapidly navigate into longer lives for ourselves. Because longevity is what I would call the game of life. So someone called Josh Mitteldorf made a very nice blog about that, playing the game of life. The goal is to find, before you die, how not to die. And that's not that easy. You need to go that way, and that's the only way.